Okay, good morning, everybody. Today, I will discuss regarding determination of unknown strength of given acid against standard sodium hydroxide solution by conductometric method. Now, first of all, we should know what we mean by conductance of a solution. Conductance, basically, we know that it is the number of ions present per cc or per ml of the solution. It is the number of ions present per cc or per ml of the solution. Now, in this experiment, their theory tells us that we have to take unknown acid, that is unknown here, actually HCl solution will be taken. HCl solution will be taken. Now, this HCl solution is a strong acid. It ionizes as H plus Cl minus. Now, a given amount of HCl will be taken in a small beaker. Say we have taken here 25 ml, 25 ml HCl solution has been taken. Now, since a strong acid, so number of H plus ion will be more, that is here H plus ion, and Cl minus ion will be there. So initially the conductance will be high because number of ions will be more. Obviously the conductance will be high. Now, when this acid solution is treated against standard sodium hydroxide solution, now what will we do here? That sodium hydroxide will be added from the borate. Since the standard solution, so its strength is known to us, we have taken the strength of NO is N by 2 NOH. Now, when certain drops of NOH is added into this HCl solution, say 10 drops we have added, enter 10 drops. What will happen? Some of the H plus ion will be neutralized by Na plus. It means acid base reaction will be taking place. H plus Cl minus plus we have added sodium hydroxide in the form of Na plus. So what will happen? The reaction is neutralization reaction NaCl plus water. Salt plus water is. Now, during the formation of this salt, what happens that conductance depends on many parameters. Already I told you it is the number of ions present per ml of the solution. It also depends on size of the ions. It also depends on mobility of the ions. It also depends on temperature also. So here, the H plus ion, due to small in size, its conductance will be high. So whenever we are adding sodium hydroxide into this HCl solution, this fast moving H plus ion will be replaced by slow moving Na plus ion, because Na plus ion is comparatively larger in size than H plus ion. So the conductance will decrease fast. Again, if we add 10 drops into HCl solution, what will happen? Again, some of the H plus ion will be neutralized by sodium hydroxide, that is, some of the acid will be neutralized by sodium hydroxide, and here also some of the H plus ion again will be replaced by slow moving Na plus ion. Again, the conductance will decrease. Now, this decrease in conductance, will go up to that point where all the acid will be neutralized by base sodium hydroxide. So, if we plot here number of drops of NOH versus conductance. What will happen? Already I told you. It's the first initial point where the initial conductance will be high. When we are adding 10 drops into it, 10 drops of energy into it, what if the conductance will decrease? And this decreasing conductance will go up to that point where all the acid will be neutralized by base. So this is a point, this is a point, this is a point. Now, if we draw this line and add this point, it will look like this. So this point, where the equivalence point, the products are NaCl plus water. So this is the minimum point of conductance, because sodium chloride is not, the conductance will be zero because sodium chloride is a strong electrolyte. So being the presence of ions present in the solution, the conductance will be, it has some sort of conductance. Now, beyond the end point, if we still add sodium hydroxide into this acyl solution, what will happen? The conductance will steadily increase because sodium hydroxide being a strong electrolyte, it gives into Na plus OH minus 1. So being the ions are present, the conductance will increase. Okay. Now if we join this point, it looks like this. Now the first line is the steeper. You see the steeper. Second line steadily increase. So not the second line is not the steeper one. This steepness due to the fast moving replacement of fast moving H plus ion by slow moving Na plus ion. Now intersection of these two lines, if we intersect these two lines, what will happen? That intersection of these two lines, what will happen? Intersection point. This point is the neutralization point. Now if we draw this line perpendicular to the number of drops of NOH, we can get the drops of NOH which is required to neutralize a given acyl solution. Now we can count these drops of NOH required for complete neutralization. Now it is found that 20 drops of NOH correspond to 1 ml. Now from this graph, if we plot this number of drops of NOH versus conductance in a graph paper, we can get the drops of NOH from this point, and suppose it is 80 drops from the graph. If we count it, suppose the x-axis, if it is the drops of NOH, say 80 drops from the graph paper, so 80 drops correspond to how much ml? 20. That is 4 ml. Now, in calculation part, what is the unknown strength of given acyl solution? In calculation part, that is what you can write here. That is what you can write. By using the law of equivalence N1 V1 equals to N2 V2. That is what you can write here. Say N1 V1. Say if it is your acid, into V2 of this. Where N1 is the normality of the acid that will be required to determine, and P1 is the volume of the acid that we have taken. 25 ml initial solution we have taken here. Initially we have taken 25 ml initial solution we have taken, and N2 is the strength of NOH that we have taken here. N by 2 strength of normality of NOH has been taken, and V2 is the volume from this graph. Say here 4 ml is the volume of NOH required for neutralization. That is V2. Now N1 into V1, how much we have taken? Initial solution 25 ml solution 25 ml equals to N2 means we have taken N by 2 strength of standard NOH we have taken, and V2 means from the graph, and 20 times equals what ml, so this is a 4 ml, that is the value of NOH 4. Now from this what we can write, N1 equals to now, so the strength of unknown strength of unknown ACL is 0.08 normal. So this is the experiment, and behind this experiment the calculation part is there. Now thank you. This is all about this experiment.